All right, so today we're going to talk about relations and functions. So then the important part of this first definition right here is right here. So a set of ordered pairs, that's called a relation. And for these, we use these, I don't know if you can see these very well, but we use these weird set brackets right here. So a set of ordered pairs, that would look something like this. So I'll just write one for you guys. So a set of ordered pairs would be like, you could have like 2 with -3. You could have 4 with -6. Maybe 6 with -9. So something like that. And again, you got to put these set brackets on there. So that right there, that's a relation. It's just a set of ordered pairs. And then they call them ordered pairs because, like, this is the x, right? The 2 is the x, and the 3 is the y. So they're ordered pairs of the form x comma y. All right, and then we can express this relation in 3 different ways. We can write them as a table, or we can show them as a graph, or the third way we can do it is as a mapping diagram. All right. And then the next blank we have there, this is all kind of vocabulary stuff for you guys. The set of all the possible x values on it, or I should say on the graph. So the set of all x values, that's called the domain. And then the set of all the y values, that's called the range. All right, so then we got example 1 down here. And they gave us a relation, so you see that right here. So they gave us a set of ordered pairs. And then we're going to represent that as a table, and then as a graph, and then as a mapping diagram. So let me slide up here. All right, so first as a table. So can somebody raise their hand and tell me the 3 x values? Sid?
2, 4, and 6.
Yep. So 2, 4, and 6. So you're going to put those in a table. That's good. So you put 2, 4, and 6. And then somebody tell me the 3 y values. Ethan?
8, 7, 8.
Well, put them in the same order so they match up. So 2 goes with what?
7, 8.
Yeah. Yeah, so the 2 goes with the 3, right? And the 4 goes with the 7, and the 6 goes with the 8. So there you go. There's the same relation in table form. Then you got to do a graph. Now, when you graph this, all you have is just these 3 points right here, okay? So it's going to be discrete, okay? They're just going to be separate points. You're not going to connect them. So let's see. Our smallest x value is 2, and our largest x value is 6. So let's go like 1, 2, 3, 4, 5, 6. And then our smallest y value is 3, and our largest y value is 8. So we'll go 1, 2, 3, 4, 5, 6, 7, 8. And then we're just going to plot these points. So 2 comma 3, that's going to be 2 right, 3 up. So that's like right here. And then 4 comma 7, that's 4 right and 7 up. So that's like about right there. And then the last one is 6 for x and 8 for y. So that would be like right up here. All right, so you guys should see that. So 2 goes with 3, right? This point right here, if you want to label it, that's 6 comma 8. All right, so that's the graph. Again, there's 3 separate discrete points. And then before I do the last one, let's write down the domain and the range. So the domain down here, that is the set of all the x values. Well, we can just look right here and see what the x values were, right? Now, you don't have to put them in numerical order, but usually you do. So let's write them down. So the domain is 2 comma 4 comma 6. All right, and then the range, that's the set of, all right, we have those definitions above here, right? Like right here. So that says the range is the set of all the y values. So the set of all the y values, that is just going to be 3 comma 7 comma 8. All right, and then that'll help us make the mapping diagram. So the mapping diagram is this thing over here, this thing. So we'll label that set on the left, we'll label that as the domain, and then the set on the right, we'll label that as the range. And then you just put the x values into the domain. So the x values were 2, 4, and 6. And then the range values, well, those were the y values. So those were 3, 7, and 8. And then you just draw little arrows. So 2 maps to 3, 4 maps to 7, and 6 maps to 8. And you can see that on the graph over here too, right? On the graph, you can see that 2 maps to 3, right? If you go like this. So 2 maps to 3. You guys good so far? No? So that was the end of that page, right? Okay, so let's flip it over. Okay, so this one, this says more on domain and range. All right, so it says do not write repeats. So when I write down, well, it's kind of hard, well, no, we'll get to that in a minute. When you write the domain, what x values do we have for this first one here, number 2?
3, 5, 4, 3, 5, 4, 3.
Yeah, but we're not going to write the repeat.
Right.
So the only x values we have are 3, 5, and 4, correct? You guys see that it repeats right there? So you don't need to write the 3 more than once, okay? You have a 3 for an x value here and a 3 for an x value there. So when you write the domain, again, that's a set of all the x values. So that is just 3, we'll put them in numerical order. So that's just 3, 4, and 5. That's all you got. And then somebody raise their hand and tell me, what are the range values? Damien?
2, -1.
And one other one.
0.
Yeah, 0 also. You see the 0 there on the third point, Damien? Yeah. And again, usually you'll put them in numerical order. So we got -2, -1, and 0, right? So we got -2, -1, and 0. And again, we don't write the -1 twice, okay? We're just saying what y values are there? Well, there's 3 y values. The range is the set of all the y values. All right, let's do the same thing then for number 3. Now, it's kind of hard to read those numbers on that thing. I'm going to call this number right here. You can't really read it. I'm going to say that's a -3 right there, okay? That's a -3, and if you can't read that one, that's a 4. Okay, so the domain again? Well, the domain is this set on the left and the range is the set on the right. So for the domain, we're just going to write down those x values. So what do we got? We got, again, putting them in numerical order, we got -4, -3, 4, and 5. And then for the range, somebody raise their hand, what's the range? Anybody? Yeah, just 2 and 1. I'll put them in numerical order, so we got 1 and 2. All right. And then the next comment up there at the top says something about lists work with mappings and tables, but not graphs. Well, a list will work for a graph if the graph is just separate, discrete points. But if you got a continuous graph, you can't list all the x values, you can't list all the y values. So let me slide up a little bit and zoom in on the graphing one here. Let's see. So the graphing one, we're gonna have to put some numbers on this graph though. So let's say we had, let's make it more interesting here. Let's say this point right here. Let's say that point right there. That's the point 1, 4. And just to make this more interesting, let's put an open circle on the end of this one. And let's say that's at, I don't know, what could it be? Here, let me do this. Put it up here a little more. So let's have this be, I don't know, 4, and have this be 2. Now let me zoom in on that graph. And I'll come back and do the domain and the range. How many points are on that thing?
2, 4.
Well, you got another point here, right? You got a point there, and a point there, and a point there, and a point there, and a point there. How many points?
Infinitely many?
Yeah, there's infinitely many points on there. In fact, just between here and the end of it here, so if you look down here, say that was at 3. Hold on. Let's say you had a point right here. And that point has an x value of like 3, okay? Well, just in this one little section right here, you can put as many points as you want in there, right? Because you could have an x value of 3, 3.1, 3.5, 3.9, 3.999, 3.99999. You could just keep doing that forever, right? So there's a whole bunch of x values just right there, right? Do you see why you can't list them all then? You can't list the domain in a list form because you can't write them all down because there's infinitely many of them. So let's do it this way. So let's, so let me get this where you can write the domain and range again on here. All right, so what we're going to do for the domain, what's our smallest x value? Yeah, you guys can see that, right?
Yeah.
Your smallest x value would be like right here, right? And what's our largest x value?
4.
Well, it's at 4, but we got an open circle there, right? So that means our domain, our x values are between 1 and 4. So you remember how we wrote those between the statements in the last chapter? So our smallest x value is 1. Our largest x value is 4. We want all the x's in between those two. So what do I put in these spots right here from last chapter, you remember?
Less than and less than?
Yeah, less than, good. So we're going to put a less than here and a less than there. And which one gets the equal to bar?
4.
Where do we get the solid dot at? We're looking at x values.
The 1.
Yeah, so this one right there, right? We got a solid dot here. That means including an x value of 1, right? So that's the domain. That's all the x values between 1 and 4, including the 1 but not the 4. And then for the range, what's our smallest y value?
2.
Yep, that's 2. And what's our largest y value? Yep, 4. So that means our y values for the range, remember the range is a set of all the y values. Our smallest y value was 2, and our largest y value was 4. And we want all the y values in between 2 and 4. So we put a less than and a less than. And then which one gets the equal to bar on this one? Yeah, the largest y value is right here at 4, right? The 2 is not included. The y value of 2 is not included because of the open circle right here. So we got to put the equal to bar here, right? Hold on. We got to put the equal to bar right there. Because the range includes the largest y value of 4 because of the solid dot. All right? So that should wrap up that part. The next part is you want to decide if a relation is a function. So pay attention to this part, okay? So it's still a relation. It's just a special case of a relation. That's what a function is. So I'm going to write down the definition of a function for you guys right here. So a function, I can fit this here. So a function, well, it's a relation. So it's a this is going to be kind of small. It's a relation where for each x, how should I put this? It's a relation where for one x value, yeah, there has to be exactly one y. Hold on. So it's kind of tough to read that, but. So a function, it's still a relation, okay? It's a set of ordered pairs, but it's a set of ordered pairs where for one x value, there is exactly one y value. Maybe I'll change this to the word each right here. All right, so it's a relation where for each x value, there is exactly one y value. And then, you don't have to write this part. What the heck?
It's like a whole thing.
And then why do we like functions? Guys, why do we like functions?
Because, oh, they're fun.
Yes, they are.
Fun for everyone.
Yes, they are. They are fun. They are functions. All right. So the fun is already built in there. All right. All right. So then, how do we look at a relation? It could be a set of ordered pairs. It could be a table. It could be a graph. It could be a mapping. How do we decide whether it's a function, yes or no? So, first of all, right here it says it cannot have repeating x values right here. If you see a repeating x value, then it's not a function. Shh. Come on, I'm recording this, you guys. So on a table, let's see, how do I describe this? On a table, you can't have the same x value. Okay? So if you see something like, for a table, I'll put an example over here on the side. If you see something like, if you see 2 goes to 5, let me make these legible. If you see 2 goes to 5 and 0 goes to 6 and 2 goes to 7, do you see a repeating x value there? So if you see a repeating x value, then you know it's not a function. So right here, you see a repeating x value. So then you know that's not a function. So not a function. Hopefully you guys can read that. It says not a function. Again, I need it quiet, guys, okay? All right, on a graph. So if you have a graph, you can't have one point, you can't have a point directly or above or below another point. So let me write that in here. So you can't have, quiet please. You can't have a point directly above or below another point. I'm going to continue this definition down here. So can't have a point directly above or below another point. Well, what would that look like? Well, that would look like, look at that little table I made over there on the right. Let me draw a little graph to go with it. So if I drew you a little graph for this one, you've got 2 with 5, right? So that would go right here. So 2 for x, 5 for y. Then you got 0, 6, so that would be like here. And then you got 2 with 7, which would be like here. Do you see a point directly above or below another point? Yeah. Because you have 2 mapping to 5 and you have 2 mapping to 7, right? That's just those points I have in that table. Well, you should see right here then you have 2 points that are directly above or below each other, right? So right there. So if that happens, then that's not a function. Again, we already knew that. So again, do you guys see that this table is the same as this graph, right? So then we know that each of these representations, this one is not a function, this one is not a function. All right, and then in a mapping diagram, you can't have one x value mapping to more than one y value. I think I'm going to run out of room here. Hold on. So you can't have one x value mapping to more than one y value. Again, that's kind of small. Hopefully you can read that. So we can't have one x value mapping to more than one y value. Then it would be not a function. All right, so what would that look like? Well, if we made a little mapping for the one that I have over here, same example, right? Let me draw you a little mapping diagram for this one. So you'd have these two sets. The one on the left is the domain, the one on the right is the range. Well, if you look at our table there, we have we have 0 mapping to 6, right? And we have 2 mapping to 5 and to 7. So 2 maps to 5, 2 maps to 7, 0 maps to 6. All right, well, if you look at that, you can't have one x value mapping to more than one y value. So right here, you can see that's not a function. So I'll put another arrow down here. So all 3 of these examples, those are not functions. All right. So now it says, go back to the ones we had above and decide whether the relations are functions or not. So let's do that real quick. So up here, number 2, do you see a repeated x value? Yeah, if you have a repeated x value, if you see 3 twice, you know right away that's not a function. So you're going to write for number 2, you're going to write not a function. Yeah, we're going back up. So that one's not a function. What about a number 3? Do you have an x value that goes to more than one y value?
Yeah.
You do?
No. Wait, no.
No.
Share y value.
Yeah, you can have 2 x values that go to the same y value. So you can have 2 x values mapping to the same y value, that's fine. Okay? Do you see a repeated x value here? No. No, so the problem is if you're doing the mapping, if you see it split this way, then you know it's not a function. If you see it go this way, it's okay. All right? So this number 3, yes, it's a function. So you're going to write, it's a function. All right? And then number 4. Do you see a point like directly above or below another point? No. If you had a point here maybe, and then you had another point there, that would not be a function. But this one is. So you're going to write it's a function. And why do we like functions?
Because they're fun for everyone.
There you go. All right. All right, let's do the last 2 real quick. Because we got to get out of here, right?
Yes.
All right, the last 2. Do you see on this graph that you have a point here and then directly below it you have a point here? Is that a function then? No. So this one, number 6, this is not a function. And then on the last one, can you see this happening? Right here? You have one x value mapping to more than one y value, so is that a function?
No, it's not.
No, it's not. So this one is not a function.